Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will go through Venn diagrams and two-way tables. So let's start with this question. 30 students, 18 play AFL, 11 basketball, 7 play neither. We're going to calculate each of these probabilities. But in order to calculate them, we would use a Venn diagram or two-way table. We know to use one of these because the question involves two sets. A set is just a collection of objects. So here we have the set of students who play AFL and the set of students who play basketball. So when you have a question involving multiple sets, use either a Venn diagram or a two-way table. The point of these is just to display the information and make probability calculations easier. So let's start with a Venn diagram. So a Venn diagram has a rectangle outside of two circles. Each circle represents a set. So we'll call the sets A for people who play AFL and B for basketball. So here we had 18 plus 11 plus 7. That actually equals 36. How is that possible if we only had 30 students? Well, that means that some play both. Because 18 plus 11 plus 7 is 36, we have overcounted by 6. The only way this is possible is if I counted 6 students in the AFL set and counted those same 6 students also in the basketball set. So however many you've overcounted is how many are in both. So there will be 6 who play both AFL and basketball. Now we already have 6 in the AFL circle. We need 12 more to make 18 AFL players and 5 more basketball players. The 7 that play neither go outside the circle. Now we could just as easily have used a two-way table. So the two ways that you can either play AFL or not play AFL. You can play basketball or not play basketball. So in this cell, we're in column A, row B. These are the people that play both. So we'll put a 6 there. These are the 12 that play AFL and not basketball. We have a row and column for totals in a two-way table. So up at this cell here, these are the people that play basketball but not AFL, so that's 5, and then the 7 that play neither go there. So we should see that these two numbers and these two numbers both add up to 30, which they do, so we know we're on the right track. So Venn diagrams and two-way tables display the exact same information. You can see the 4 numbers from the Venn diagram are precisely the 4 numbers here. So now we're ready to answer some probability questions. This first one says probability of A and B. This one means and. So we're looking at the probability. If I select a student at random, they play both AFL and basketball. Well, there's 6 of those out of 30 in total. And make sure if you're giving your answer as a fraction that it's simplified. This says A or B. So this includes everyone who plays AFL or plays basketball or both. We include the both in this case. So there are 12 plus 6 plus 5, 23 students in total who play AFL or basketball. Another way of saying this, it's the number that play at least one of the sports. So this dash here means not. This says the probability they don't play AFL or they don't play basketball. So generally in these questions, in fact almost always, if it's an and question, you need to get 1 number from the Venn diagram, and if it's an or question, you need to get 3. The 3 numbers we need here, we want all the people who don't play AFL, so that includes these people. We also want anyone who doesn't play basketball, these people. See, all of these people highlighted don't play at least one of the sports. So adding those up, we get 24 out of 30. And once again, if you give your answer as a fraction, make sure it's simplified. So this line here means given that. So this says probability of A given that B. The probability that they play AFL given that they play basketball. So I'm saying I know they play basketball. So that gives me 11 choices. There are 11 people that play basketball. Of those 11 who play basketball, 6 also play AFL. So it's 6 over 11. So this one says the probability of not B given that not A. That means we know that they don't play AFL. So that's these 12 people here from which we have to choose. Of those 12 who don't play AFL, 7 of them also don't play basketball. So it's 7 over 12. All right, let's look now at a harder question. So a business orders bottles of Coke and Pepsi, 80% of which are Coke, 3% of Coke bottles, 4% of Pepsi bottles are defective, they don't contain the right amount, and we're going to calculate this probability here. Once again, we have a question involving 2 sets, Coke and Pepsi, so we're going to use a two-way table or a Venn diagram. So because we're given information about the total of each, I'm going to use a two-way table. I think it's easier. So from the information in the question, we know each bottle is either Coke or Pepsi, and that it's either defective or not defective. By defective, I mean doesn't contain the right amount. Remember that two-way tables always have a column and row for the total. That's why I thought it would be good to use a two-way table here. So it says in the question 80% of bottles are Coke, so that must mean that 20% are Pepsi. So because we're dealing with percentages here, they must add up to 100. Now it says 3% of Coke bottles are defective. So what goes here, Coke and defective, is 3% of 80. So that is 2.4%. 2.4% of all the bottles are defective Coke bottles. And these two numbers have to add to 80, so this will be 80 minus 2.4, 77.6. Now we're going to do something similar here. It says 4% of Pepsi bottles are defective. So that is 4% of this 20%. So 4% as a decimal is 0.04. And if you times by 20, you get 0.8. 0.8% of all bottles are defective Pepsi bottles. So this number here must be 19.2, as these two must add to 20. So adding up these two, we get 3.2. Adding up these two numbers, we get 96.8. So that's a good sign because these two also add to 100. So we know we're on the right track. Now the question asked us to calculate the probability that it's a Coke bottle if I know that it is not defective. So another way of saying that, we're calculating the probability it's Coke given that it's not defective. So there are like 96.8 choices for defective. 96.8% of the bottles are non-defective. Of those, 77.6% are Coke bottles. And if we put that in our calculator, we get about 0.8. Doesn't matter whether you write a probability as a fraction or decimal, either is fine. All right, let's now look at a three-way Venn diagram. So here we have lots of information about pet ownership, 50 students in total. We are going to go and put this information into a three-way Venn diagram. So when you have 3 sets, you basically have to use a three-way Venn diagram. There's no three-dimensional two-way table. So here again, we have a circle for each of the sets. So we can't just go and start putting in numbers. We can't put 8 here, for example. 8 own a bird. That includes all of these. But what we do know is that 2 own all 3. So we will put 2 here. Now it says that 5 own a bird and a dog. This is bird and dog. We already have 2 in this area, so we need another 3 here. Similarly, 3 own a bird and a cat. We need 3 in this area, so it must be 1 that goes there. Now since 8 own a bird, 3 plus 2 plus 1 is 6. We need 2 more. The 6 that own none will go out there. But here, we can't really go any further. We don't know any of these numbers here. So what I'm going to do is I'm going to let this number here be x. Now we know that 20 people own a cat, so these two numbers here must add to 17. So if this is an x, this one here I can write as 17 minus x. Similarly, 30 own a dog. We have 5 already in the dog circle. These two must add to 25. So if this one is x, then this one here must be 25 minus x. Now I can figure out what x is, which number goes here, from the fact that all of these numbers must add up to 50. So I've got 8 in the bird circle plus the 6 that own neither, plus these 3 numbers here adding to 50. Now this is a very easy equation to solve. Note, of course, minus x and plus x just cancel each other out and add to 0. So I'm left with 14, 31, 56 minus x equals 50. So you can probably see that x has to equal 6. So I'm going to substitute x equals 6 here, here, and here to complete the three-way Venn diagram. So now that the Venn diagram is complete, I can turn my attention to this. This says the probability they own a cat and a dog given that they don't own a bird. So let's look at the second part first. Let's look at those that don't own a bird. So that is all of these people here. There are 42 options in total for people that don't own a bird. Of those 42 options, we can see that 6 of them own both a cat and a dog. So the required probability is just 6 over 42 or 1 over 7. Thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.